Good morning. This lesson is for my Trig-Precalc class. This is Chapter 2, Lesson 1. But before I get started, I want to say that I hope everyone is doing okay out there. Let's go ahead and just jump right in. Just got an email. Let's jump right in. Our first goal is going to be to interpret function notation, translate what it means, maybe look at it in a different set of lenses, simplify the concept. Our second goal will be hopefully using this simplification of what function notation actually is telling us. And I'm going to define even and odd functions. I'm going to determine if equations are, in fact, even, odd, or neither. All right, so let's just jump right into this and see how this goes. Okay, so I have my first goal, and I want to interpret this this little equation: f of 2 is equal to negative 3. Math started making a lot more sense when I was able to internalize it and think about it using different language than mathematical language. And I find that a lot of students, when I make it less mathematical and talk about the concepts using everyday terms and concepts, my students are able to, conceptually understand what's going on. And we get a lot farther with the goals that I'm trying to accomplish. Whereas if I use the strictly mathematical language, not only am I talking to you in a different language, I'm teaching you a new concept, so it's doubly hard. I like to teach the concept, get familiar with it, and then add the more mathematical language later on. And so I'm going to try and do that with this lesson. I'm going to try and simplify it using everyday terminology. And then hopefully that's going to be a way for me to teach the conceptual ideas, and we'll have a deeper grasp of what this lesson is actually about. All right, so my first goal, I have this again, like this very incredibly complicated, not incredible, but this mathematical statement. And so, to be honest about this mathematical statement, it's telling me two things. It's telling me left and rights and ups and downs. And if we think about statements like this as lefts or rights and ups or downs, I think that these are concepts that we can wrap our mind around. I understand the idea of left and right, and I'm pretty sure you do too. And I'm pretty sure you understand the idea of ups and downs. So what this is telling me, very simply, is it's telling me that when I go 2 to the right, 2 right goes down 3. So again, this is I'm trying to demathematicalize. I don't think that's a word, but who's gonna keep me from saying that? But if I go 2 to the right, then I go down 3. And so this statement is telling me my lefts and rights, which is the number inside the parenthesis, that's my lefts and rights, and then the number that it's equal to, that's my ups or down. We can also consider this whole f of whatever as an up and down. And sometimes you see ordered pairs written like this, and it furthers the argument that this is your left and right because that's your x value, and this is your y value, or your up and down. So remember, when I'm talking to you in function notation, I'm telling you ups and downs, or lefts and rights and ups and downs. All right, so if you think about it like that, we get to this second goal, which is defining an even function. And when I'm defining an even function, I'm literally saying, and I'm going to translate this to you, when I go left and right the same distance, I get the same height. That's literally what this is saying. So go left and right the same distance. So if I plug in opposites, I'm going to get the same output. Okay. So let's just see an example of a problem that's actually what we would call an even function. So if I give you something that looks like this, f of x is equal to x squared plus 4, and two simple opposites would be, let's plug in 5, and we'll also plug in -5. So again, I'm going left and right the same distance. And if this is an even function, I should get the same output or the same height from this. So let's see here. 5 squared, that's going to give me 25. 25 plus 4, that's going to give me the 29. So when I go 5 to the right, I get a height of 29, or an up of 29. And when I go 5 to the left, -5 squared is -5 times -5. That's 25. 25 plus 4, again, is 29. So this is behaving like an even function. You're going to want to plug in a couple more points just to make sure that it's not a coincidence that it worked out. But, you know, again, this is saying if I go left and right the same distance, I should get the same height. That's what an even function is. All right, let's translate this odd function. All right, and so what this is saying is if I go left and right the same distance, if I go left and I go right the same distance, I'm going to get opposite heights. Okay. So going left and right the same distance, just like before. So let's look at an example of an odd function. And this negative, I was thinking about it's going to throw some of us off. But I think that if we see an example of an odd function, it'll make a little bit more sense to us here. So an odd function would be something that looks like this. Oh, no, not like that, sorry. We'll say, all right, so we'll pick small numbers for this one because I'm cubing it, right? I'm multiplying it by itself 3 times. So we'll go to the right 3 and we'll go to the left 3. If I go to the right 3, that means that I'm multiplying 3 to itself 3 times. So 3 times 3 is 9, 1 more 3 is 27. Let me do that. So here I have 27 plus 6, and that's going to take me to 33. If this is in fact an odd function, then this value should be -33. All right, it's because when I go left and right the same distance, I'm going to get opposite heights. Okay, so let's see here. So I get -3 cubed. -3 times -3 is +9. +9 times -3 gets me to -27. -27 plus -6. If I owe you $27, I owe you $6, you're going to tell me that you owe me $33. So here I'm going left and right the same distance, and I'm getting opposite heights. Now, it throws me off. Honestly, in this equation, this part throws me off. That negative throws me off. It literally does. It's like, well, how can they be equal, you know? So if we think about this, if we add a parentheses around this, okay, what that does is this now says that I'm switching the sign of whatever this is, and it's going to be the same as that. So if I switch the height of this from a negative by that, then I get to a positive. Or if I switch the height from a positive to a negative, these heights are the same. So this equation is going to be true if these heights are opposites, because this negative sign changes one of these, and so now they match. And again, this bothers me in the equation or in the definition of an odd function, but you know, in working it through and then going back and see how it ties together, I think for me personally it helps, and hopefully for you guys it does as well. I know that this is kind of an odd lesson where I'm just talking about notation and translation. But remember, you guys are heading to higher level mathematics, and when we get to higher level mathematics, we start communicating ideas to you more mathematically. And so if we don't ever get comfortable reading definitions of math in a mathematical sense. We're going to struggle at these higher levels of math, but again, for me, I try to turn it into phrases that I understand, lefts ofs and right ofs, or ups or downs. And so for me, I find that when I break these what appear to be complicated looking sentences down to lefts and rights and ups and downs or heights, um, it simplifies it for me. And so this will take a couple, it'll take a little practice getting used to this. But again, the further we go into mathematics, the more mathematical the ideas are going to be taught to us. So we need to get comfortable interpreting these things. So again, I hope that this makes sense. I know that I'm going to have to do a couple more of these lessons because I haven't talked at all about what the graphs look like on this. I've only talked about what it looks like as a function. So there is a bit more, and we'll spend some time on it, and hopefully I can help us wrap our minds around this. But again, this idea of even and odd functions is important when we get to trig. So I want to plant this seed at the beginning of the year and get us to have a really comfortable, good conceptual understanding of what this actually means. So that's going to end the lesson today. Again, I hope everyone's doing all right out there, and I will see you guys later. Bye-bye.